First lesson of our new chapter. This chapter is on counting and then probability. One of the things that we have to do when we count is to make sure that we don't double count things. Otherwise, that's going to throw off our results later on. So we'll start with this problem. We have people that like chocolate, butterscotch, both, and then we have some that don't like any. One of the things that we're going to do is try to figure out how many people were surveyed in this group. And it's a little more involved than just adding up all the numbers. We're probably going to double count people if we do that, and that's going to throw off our data. So we need to determine how many people are in each individual group. One of the ways we do that is with something called a Venn diagram. You've probably seen these before. A couple of circles that overlap and so on. And that's pretty much what we'll do here. We have two groups, one chocolate, one butterscotch. So I will create two circles. This one, C for chocolate. And then I will draw a second circle overlapping the first. We'll call this B for butterscotch. This area where they meet is where they overlap, and that's where this value goes. 59 people like both. In other words, 59 people are in both circles at the same time. We also tend to do this, draw a box around those circles, because here we have 19 people that don't like either one. Not sure how you could be in that group, but oh well. I'm obviously in the one that likes both, but to each his or her own. So 19 people will go there, and that's the purpose of the box, is to give these people a place to live. Since they can't be inside the circle, they're inside the box. Now here's the power of a Venn diagram. We know that there are 218 people that like chocolate. This is the entire chocolate circle. There are 218 people in that circle, but that circle is in two parts. Some of the people like chocolate and butterscotch. Some people only like chocolate, but not the other one. So we need to subtract out this 59 from this total group. And when we do that, we will get 159. There are 159 people of this number that like chocolate only. We'll do the same thing with butterscotch. 178 people like butterscotch, but 59 of them also like chocolate. So I will subtract 59 from here to get 119. And now I can see exactly how many people were surveyed. 159 people here, plus 59 people in this group, plus 119 people in that group, and then don't forget the 19 there. We end up with 356 people total that were surveyed. Had we just added up all these numbers at the start, we would have ended up with over 474. And you can see that we had way overestimated that value. So that's how many people were surveyed. How many people like chocolate only? This amount right here, 159. So that's a very simple two-circle Venn diagram. Now let's crank it up a little bit. Here we're surveying people about what they like on their hot dogs. 44 people were asked what they like, and they were given a choice: ketchup, ketchup, mustard, relish. Again, I would be one of the 6 that like all 3. And then we can see the various results here. Now there are 3 circles, and here's where it gets a little tricky. So I'll give you a moment to look at all this. Our question is, how many people don't like any of these? Well, we have the total, we have the breakdown of all the groups, we just don't know who's in this group. So to do this, I'm going to draw 3 circles. I'll call this one the ketchup circle. I'll call this one the mustard circle. And I will call this one the relish circle. And I will make my space here where all the circles live. And now we see that we have a lot of different groups here. Here's the big ketchup circle, but it's split into 4 parts. Ketchup only, ketchup and mustard, ketchup, mustard, and relish, where all 3 circles meet. And here's ketchup and relish, but no mustard. So we have a lot of different things going on here, and we have to be very careful. My piece of advice is try to start in the middle or in the inside and work your way to the outside. For example, 6 people like all 3. That goes right there. 11 people like ketchup and relish. Now, wherever ketchup and relish overlap is where the 11 is. So this right here is not 11. Ketchup and relish is both of these sections. Both of these sections have to add up to 11, which means 5 will go there. It does not say ketchup and relish only. It just says ketchup and relish. So we have to assume it's that combined area. Let me back up to our problem here. One of our statements was 28 people like ketchup. 13 like ketchup only. And that word only is a big key word. 13 like ketchup only, 28 like ketchup total. So what that means is all of these sections will add up to 28. This is the only. So we know there are 13 there. We know the ketchup circle has to total 28. So here's 18, 6 more is 24, and that tells us what this section is, it's 4. If I add up all the parts of this circle, I should get 28. That's the ketchup circle. Let's see what else we have. 10 like ketchup and mustard. Ketchup, mustard here, that does add up to 10. So that part's done. Mustard and relish is 8. Mustard is red, relish is blue, so here's where those 2 meet. Total is 8, which means this part is 2. 20 people total like mustard. Here's the mustard circle. We're missing 1 piece. We know it adds up to 20. 10, 12, and that becomes 8. 14 like relish. Here's the relish circle. We have 13 already. That means only 1 person only likes relish on their hot dog. We have all the parts except for 1. We don't know how many people are out here. So adding up all these parts, we have 17, 25, 27, 33, 34, 39. We know there were 44 people that were surveyed. 39 people are in the circle. That means 5 people have to be outside of the circles. That is a 3-circle Venn diagram. Again, if I add up all of these parts, I should get the total number of people surveyed. If you encounter anything larger than 3 circles, this is what it would look like. Here is a 4-circle Venn diagram, and you can see that the number of spaces has increased a lot. Sometimes instead of circles, they will use ellipses because you can stretch them a little bit and make them fit a little nicer. 4 circles, though, isn't bad, but look at all these different combinations of groups. The B circle, for example, you've got just B, just A and B, just B and C, it's like B and D is, there should be a B and D only that appears to be missing. It's covered over here, B and D only. And then you can see that there are a lot of groups of 3, a lot of groups, another group of 4. It gets a lot more complicated. And then you think that was bad, here's 5. The circles, it's hard to get the circles to show just exactly what you're looking for. So here, now again, they're using ellipses. You can see that they have all of the groups covered. Again, B and D only appears to be missing from here because it's very difficult to just get those 2 with circles. B and D only on the ellipses, it's a little hard to see, but it is in here. It's one of these little tiny ones over here. Very, very difficult to do a 5-group Venn diagram. For our purposes, if we have to do these, we will stick to 2 and 3.